NASA's Lunar Trailblazer probe lost in space. NASA's Lunar Trailblazer probe has slipped silently into the cosmos, its groundbreaking quest to map lunar water ending in an inauspicious silence. The mission's abrupt end marks the latest challenge in NASA's ambitious Simplex program, a cost-conscious initiative embracing calculated risks to accelerate space exploration. 1-4. But here's where the story gets fascinating. Could this failure actually pave the way for bolder future missions? Let's unravel this cosmic puzzle step by step. A misstep in the moon's shadow. Launched alongside the second Intuitive Machines lunar lander on February 26th, the Lunar Trailblazer initially performed flawlessly before encountering a critical misorientation. Its solar panels, critical for powering operations, failed to align with the sun, draining batteries and trapping the craft in a slow, inescapable spin. Ground control gambling on a potential recovery after battering data suggested a power rebound, only to find the probe's weakened signal would never pierce Earth's reception. The core question remains, was this mission a risk worth taking? The Simplex dilemma, science versus sustainability. Selected through NASA's Small Innovative Missions program, the Trailblazer exemplified Simplex's cost-cutting ethos. By reducing oversight and adopting modest objectives, the program aims to produce more frequent scientific forays. But here's the million-dollar question. Can streamlined missions balance budget constraints with meaningful discoveries? Echoes of the faster, better, cheaper era. This isn't NASA's first brush with high-risk strategies. The 1990s faster, better, cheaper philosophy birthed triumphs, Mars Sojourner, and failures, Mars Polar Lander. Could history repeat? With modern budget pressures tightening, NASA appears doubling down on this approach and raising critical debates about reliability versus innovation. 1. What's at stake and what's next? The Lost Probe aimed to 1. Map lunar water, charting presence, composition, and time-based changes. 2. Enable future missions, data for both automated and human exploration plans. 3. Test new methods, prove cost-effective mission frameworks. But recovery attempts in July revealed an unavoidable truth. Even if power had returned, Earth's receivers stood no chance of catching the Trailblazer's faint heartbeat. Controversy time. What do you think? Is this experimental approach, the Simplex philosophy, a necessary evil in space research, or a recipe for repeated misfires? Should agencies prioritize mission success rates over innovation pace? Add your take below. The conversation matters. NASA's Lunar Trailblazer mission ends. What went wrong? Moonbound dreams deferred. The untimely end of NASA's Lunar Trailblazer. Imagine a future where humans thrive on the moon, harnessing its resources to propel further space exploration. A crucial step towards this vision was NASA's Lunar Trailblazer mission, which unfortunately met an untimely end on July 31st. But here's where it gets intriguing. Despite its demise, the mission's legacy is set to illuminate the path for future lunar endeavors. The ambitious quest. Lunar Trailblazer was designed to craft ultra-high-resolution maps of water on the moon's surface, deciphering its form, quantity, and temporal variations. These invaluable maps would have paved the way for both robotic and human lunar exploration, as well as commercial ventures, while shedding light on water cycles across airless solar system bodies. A shared ride to the stars. On February 26th, Lunar Trailblazer embarked on its journey aboard the Intuitive Machines IM-2 robotic lunar lander, launched via SpaceX Falcon 9 rocket from Kennedy Space Center. The small satellite successfully separated from the rocket 48 minutes post-launch, establishing initial communications with Caltech's IPAC in Pasadena at 8:13 p.m. EST. However, the celebration was short-lived, as contact was lost the very next day. The insurmountable hurdle. Without two-way communications, the team was unable to diagnose the spacecraft's issue or execute the necessary thruster operations to keep Lunar Trailblazer on course. And this is the part most people miss. Unfortunately, the limited data received indicated a critical misalignment of the spacecraft's solar arrays, leading to depleted batteries. A global effort to revive. For months, a collaborative effort involving organizations worldwide attempted to re-establish contact, tracking the spacecraft's position via ground radar and optical observations. These efforts revealed Lunar Trailblazer was in a slow spin, drifting into deep space. But was it enough? Models suggested that as the spacecraft might receive more sunlight, potentially recharging its batteries to reignite its radio. Alas, as time passed, the signals became too weak to recover. Technological legacy lives on. Despite the mission's end, its innovative spirit persists. The High-Resolution Volatiles and Minerals Moon Mapper, HVM3, and the Lunar Thermal Mapper, LTM instruments, developed by JPL and the University of Oxford, respectively, are testaments to groundbreaking collaboration. A controversial question arises: should the high-risk, high-reward approach of missions like Lunar Trailblazer be more prevalent in space exploration, potentially leading to more breakthroughs? The future is not canceled. Some of this pioneering technology will see new life in the JPL-built ultra-compact imaging spectrometer for the Moon, UCIS Moon, selected for a future orbital mission. This instrument, boasting an identical spectrometer design to HVM3, promises the Moon's highest spatial resolution data on surface water and minerals. Lunar Trailblazer by the numbers, selected by NASA's Simplex competition for low-cost, high-impact science missions, led by Caltech, with JPL providing system engineering and mission design. Key partners: Lockheed Martin Space, University of Oxford, funded by the UK Space Agency, managed by NASA's Planetary Missions Program Office for the Science Mission Directorate. We want to hear from you. Do you think the risks taken by Lunar Trailblazer were justified by its potential scientific breakthroughs? How do you envision the future of lunar exploration and resource utilization? Share your thoughts in the comments below. NASA's Lunar Trailblazer mission, a bittersweet end. Losing contact. NASA's Lunar Trailblazer mission meets an unexpected end. Imagine a spacecraft designed to explore the Moon, only to fall silent just after taking its first steps into space. This is exactly what happened with NASA's Lunar Trailblazer mission, which officially concluded on July 31st. Despite the initial excitement and anticipation, the mission faced a significant setback when the satellite lost contact with Earth shortly after its launch. The Lunar Trailblazer was part of the IM-2 mission, a collaboration between NASA and Intuitive Machines. It launched aboard a SpaceX Falcon 9 rocket from Kennedy Space Center on February 26 at 7:16 p.m. Eastern Time. Everything seemed to go according to plan initially. The satellite successfully separated from the rocket about 48 minutes after liftoff. Ground Control in Pasadena, California, made first contact with the satellite at 8:13 p.m. Eastern Time. However, the next day, communication was mysteriously cut off, and despite multiple attempts, the team was unable to re-establish the connection. From the limited data received before the satellite went dark, it appears that the craft's solar panels did not deploy correctly, leaving them unable to face the sun. This critical failure led to the draining of the satellite's batteries, effectively ending the mission. This is the part most people miss. Even with advanced technology, space missions can still be incredibly fragile and susceptible to unexpected issues. Nikki Fox, the Associate Administrator at NASA Headquarters Science Mission Directorate, reflected on the mission's outcome. While it was not the outcome we had hoped for, mission experiences like Lunar Trailblazer help us to learn and reduce the risk for future. Low-cost small satellites to do innovative science as we prepare for a sustained human presence on the Moon. The dedication of the Lunar Trailblazer team throughout the mission, from launch to its unfortunate conclusion, is commendable. The Lunar Trailblazer was one of several missions planned to reach the Moon by 2025. Its primary objective was to create detailed, high-resolution maps of any water present on the Moon's surface, assess the quantity and form of this water, and study how it has changed over time. Understanding the distribution and nature of lunar water is crucial for future manned missions and potential long-term habitation on the Moon. But here's where it gets controversial. Some experts argue that the focus on small, low-cost missions might come at the expense of more robust, comprehensive studies. Is the trade-off worth it? Or should we prioritize larger, more reliable missions? Fingers crossed that the remaining lunar missions will have better luck. What do you think? Should NASA continue to invest in smaller, riskier missions, or should they focus on larger, more reliable projects? Share your thoughts in the comments below.